Hi, everyone. My name is Bill Fisher, and I'm an engineer here at Facebook. About a year ago, I was frustrated that people were trying to reuse React as the view layer in their favorite MVC. So I decided to create the Flux to-do MVC example and provide some Flux documentation. Shortly afterward, Jing Chen, who is with us here today, announced Flux, or discussed Flux at the Facebook F8 conference, and people really started to take notice. I've really been happy with the result. People have embraced Flux as somewhat the de facto architecture for building applications with React. But there's a lot of questions still floating around about Flux, and so that's why we're having this panel today to sort of bring up some of those questions and discuss them. So, as I mentioned today, we have Jing Chen, the original author of Flux and one of the driving forces behind Relay, Facebook's new application framework that works with GraphQL to do data fetching in React. Let's see, to the left of her, your left, we have Kyle Davis, who works on Facebook's most powerful ads management and authoring tool, the Ads Power Editor. Ian Obermiller here from Facebook's Seattle office has been working for the last year and a half on the Atlas application, which provides advertising effectiveness tracking. Spike Brem from Airbnb popularized the term isomorphic JavaScript and is now migrating Airbnb's JavaScript to React and Flux. Michael Ridgway from the Yahoo Media team has pioneered isomorphic Flux, and his Flux implementations are now influencing much of how Yahoo engineering is approaching their JavaScript development. And from SoundCloud's New York office, we have Andres Suarez, who has a different approach to isomorphic Flux. He has developed multiple Flux applications as part of SoundCloud's advertising platform. So let's get started. Jing, I want to ask you right away. After the big announcement yesterday about Relay, I'm sure a lot of people were wondering, in what way is Relay related to Flux, or is Flux now going to quickly become a thing of the past?
Do I get kicked off the panel if I answer this badly? I mean, I think, first of all, I just want to say thank you to Bill, who has actually done a lot for Flux in popularizing it and answering questions. So used up 30 of my seconds. OK. Answer for Flux and Relay. I would say that Relay is going to solve problems for a very specific set of applications. If your application is big enough and if your team is big enough, then it's going to solve some of those problems. But I think Flux is sort of more widely applicable. It's just an idea. It's an architecture, and you can actually use it in a lot of different ways. And I think the fact that there's so many people here means that indicates that Flux has sort of grown in different ways from where we first started with that. And I think that's great, right? Like, it is sort of an idea, and I think as David Nolan pointing to, it's just one way of sort of solving some of the problems that we've seen with React. On top of that, I think for people who are using Flux now, when we do open source Relay and you try that out, there is a migration path, right? Like, you can sort of start with getting your data onto GraphQL, and then from there you can convert pieces at a time. But I think the two actually work well together. And we do have one app that we're working on where data is fetched through Relay, but there are actually customized stores for the data. And so there is sort of a boundary where you can actually have both working in the same application.
OK, great. Since let's talk about data fetching in a traditional Flux application. Kyle and Ian, you both work at Facebook, but you're taking different approaches to how you get data from the server. I'd like to hear about the pros and cons of your two approaches. Kyle, let's start with you. I understand that in Power Editor, you make calls to the server only from the stores, and I'm wondering, instead of the action creators, and I'm wondering what drove that choice.
Yeah, so in Power Editor, we only make calls to get data from within the stores. So Power Editor is a really large application. We have 106 stores, and 64 of them have to go and fetch data. So as we've been using them, one of the patterns we started to notice was we would frequently get data from the store, and then if it wasn't there, we would immediately ask for it to go be loaded. So just to simplify that whole process, we moved the data fetching into the getters of the stores. So inside the store, if it's not already in the cache, it will just go to the server and get it ready for the cache. And so that's made all of our stores really easy to work with. You just ask for the data, and eventually it will be there. Then another important thing for Power Editor is that like we're undergoing this sort of switch in our web API layer right now. So when we're upgrading a store from talking to one web API to the other, it's nice to have all of the data fetching stuff in one place in the store. So we can just upgrade our store where all of the data fetching logic is, and all of the controllers that are like consuming the store's API, they don't actually have to change, right? Because they don't have to like call out to an action creator or something else to actually tell something to go load the data. So that was really nice. And then the third thing that we found was a lot of times when you're constructing the requests to go get the data, you actually need information about what you already have. So let's say you're refreshing a list of posts. When you're building that request for the server, you need to tell the server what's the most recent post I already have. So you can be like, I want you to go refresh the post from now up until this post. That way you're not refetching your entire list. And so that's exactly what's in the store. So naturally, it just was easier to construct the request there.
Cool. Now, Ian, you're keeping everything in the Actions Creator. Contrary to that, what benefits do you see by doing that?
Yeah, so it's actually not quite everything. We're actually really similar on the fetching side. Everything goes through the store in the same way because of the whole caching layer. And it also allows us to abstract things like if you went from fetching paging data on the server, and so you have like 20,000 items and you want to take like 100 at a time, or you have maybe a smaller data set and you want to just convert that to like loading everything all at once, downloading it all at once, and then fetching it in small batches, and then like sorting and filtering it on the client to keep things really fast. The way we're a little bit different is that all of our writes are actually still in the action creator. So in that way, the action creator fires off an asynchronous call. It's usually promise-based. When it comes back, it fires off actions to just say like, hey, this thing updated, or hey, this thing failed updating. It's also a great place to do optimistic updates, because before you even send off the call, you can say like, hey, I'm going to update this. So if you want to optimistically update the UI, you can do that. And part of the reason we do it in actions and not in stores is because you have different stores that might want to listen for the results of that. So you might have composite stores or something like keeping track of a count or something else that might want to invalidate its cache in response to, say, like some new object being created.
Yeah, and so it's difficult to screw up in a way if you do it in the action creators, because even if you do it in the stores like you're doing, Kyle, if you create a new action, you have no problem. You know, your other stores can listen to that. But if you do it in the action creators, there's no way you can mess up. So, Kyle, I also wanted to ask you about the Power Editor application. It's very large, and I'm kind of wondering about performance issues in an application that large. I mean, you know, the dispatcher's gotten some flack about being synchronous, and people are like, how does that scale? But like, you know, I kind of want to know how that scales to be having 106 stores? Yeah,
106. Yeah. So as we started hooking up more stores and controllers, we started to notice our interface getting like a little laggy and slow. And so this for a few reasons, and one of them I'm going to talk about right now. We started to notice that when you have two stores, it's possible that they respond to the same action. So if you have store A and store B, and they both respond to an action and they both update their cache, then they'll both emit a change. And so what we were noticing was that when we have these controllers that are listening to both stores, what would happen is as soon as the first store emits a change, it would update its state. Then once the second store emits a change, it would also update its state again, even though it's for the exact same action. And so this was not great. So when we would just load our application, I think we had, across all our controllers, 237 calls to calculate state. That's just like loading the page and not doing anything. And so it was really bad. And then when you just make a simple change, it would fire off 87 updates to the state across all our controllers. And it's not a super expensive method, but it's not free. So it was pretty laggy. So one of the easy optimizations we did was to just debounce these calls to calculate state based on like the dispatch loop. So after doing that, it would basically like wait for the dispatch to finish and then update the state if any of the stores changed. So after doing that, we got from 237 down to 58 changes on load. And then on change, it went from 87 to like 24. So that's like 75% fewer. And it was just like a really easy change. So it was pretty good.
Great, thanks. The Atlas application is also very large. One of the things that you mentioned to me when we were talking once is that you have very few dependencies in your stores. And I'm wondering, how do you do that? How do you keep your stores from having dependencies?
Yeah, so we're not quite as large as Powder. We're only like 93 stores. So, so what Bill's talking about, dependencies, it's like when you have, say you have store A, and when the component makes a request to store A to get some data, store A might have to go talk to store B to get some other data, and then it does something with that data and then returns it to the component. Now, once you do that more, so you might have like B also might grab something from C, or A might also grab something from C, and you're with this kind of really big dependencies within your stores. And it gets confusing and it gets hard to maintain. So one of the things we do there is the component is actually responsible for this. So instead of just asking store A for data, the component will ask the data that it needs from store B. It'll fetch that, get it back, and then pass that to store A and get the data that it needs. Now, this sounds like fairly complicated, and it seems like there's a lot of logic you'd have to write there. So what we've done is wrap that all into a mixin, and it's very similar to something that Jason presented and similar to some of the GraphQL concepts where you can specify, for this field in my state, here's how you fetch it, here's what store you get it from, and most importantly, here's the data that call depends on. And that data can come from props, and it can come from state. And what we do is we're really smart about this is when any props change, we can go through all of those fields and figure out if any of the data that depended on changed and then refetch it. And this allows you to have somewhat complex, I need to fetch this and then this and then this from different stores, and then finally I ended up with data at the end that I wanted. And it makes that really easy, and fast.
Cool. And kind of along those same lines, how do you make your application more maintainable you have a large team working on it. What are your techniques for keeping a large application really maintainable?
Yeah, so we're at about 160,000 lines of code, and we have about 10 developers working on our code base actively. And if you haven't got this from React yet, one of the biggest things you can do is write a lot of components. So we componentize everything. It's great for performance, but it's also great for maintainability. To give you some numbers, we have over 700 components in our app. That was just doing a line count on anything that says React.create class. So that doesn't mean each one is a file. Some of those are when you have one big component and you have sub pieces within it, even though they may not warrant being in a separate file, you can break those out into separate components in the same file. Along the same lines as maintainability, we also keep our stores separate from each other. So say you're in email and you're fetching threads and you're fetching messages. A lot of times, your API will be optimized in that you can fetch a list of messages or fetch a list of threads. And you can also get the messages for all of those threads. Now, it might be tempting to just then stick that in the thread store, and you can just kind of pull it all out at once, right? But what that leads to, the better option actually is to have a thread store and a message store. When the data response will come back, you can shove all of the messages into the message store, let the thread store handle maybe just the list of message IDs. And basically, you keep your data separate. And what this is really great for is when you have, say, some other API call that also returns messages. They're actually the same messages. Why should they live in two separate stores? You can easily get into places where you have two different stores with the same data, but now that data's changed and you don't have a consistent worldview. That's something that bit us initially, and we've moved away from it and normalized all of our stores so that data lives in one place. Cool.
All right, I want to take a turn here and turn toward isomorphic Flux and hear from some of the people that are using isomorphic Flux at their companies. We're not doing a lot of that here at Facebook, but there are some other significant companies that are doing that. Andres and Michael, you two in particular, the two of you are doing isomorphic Flux, but you're taking different approaches particularly to your stores. SoundCloud is using store singletons, and Yahoo is using store instances. So Michael, I'd like to hear from you first. What are you gaining by using store instances rather than singletons?
Yeah, so we knew that we wanted to be able to reuse as much of the code as possible when we were rendering server-side, which is something that we needed for our applications because we need the SEO and we need the performance benefits that you get for showing the content right to the user immediately. So we kind of looked at Flux as a way of getting to a certain application state. So we kind of take the actions that you would normally execute to get to that state, call them on the server, and then populate the stores from that data. Now, in order to avoid concurrency issues in Node.js, we made the stores classes, and we instantiate them per request. And this basically allows us to avoid those concurrency issues that you would get with singletons. And then by having them as instances or classes and instances, it also adds testability because we won't have side effects between tests. And we also gain the ability to regulate the flow of Flux because stores will not have access to the dispatcher, so they can't actually dispatch an action through the system.
Interesting. Now, I understand that you also are using something called dehydration and rehydration, and there's been a lot of excitement about that in the open source community. I'd like to hear a little bit about how that works.
Yeah, so I mentioned that we create the store instances per request. So we basically have this wrapper that on each request, we create this wrapper context. And each context has its own dispatcher. And the dispatcher knows about all of the stores that have been registered to handle a certain event or a certain action that goes through the system. So when an action goes through the system, we instantiate the stores as they are listening for that event. And then at the end of the execution, we can basically say, give me all the stores that have been used on the server and call the dehydrate function on them. And that's a function that just says, this is how I can represent my state and have it serialized down to the client. And then, so when we get back down to the client, we rehydrate all those stores back to the state that was on the server. We can basically just render React on top of the existing DOM.
Wow, super cool. OK, Andres, let's hear from you about your server-side singleton stores. How does that work in your applications?
Yeah, so we use singleton stores on our Flux applications, kind of like the stock Flux pattern. You do have the situation where you could have, if you have concurrent requests, that you are going to have collisions between the stores. So the way that this actually works for us is we don't use Flux for fetching data as part of the server cycle. What we do is that gets handled somewhere else. That then gets passed along to an initialize action that preps the store so that the components can then use whatever data, and then that is what's actually sent to the client. There are situations where like you do want to do a little bit more. So one of the tricks, or I guess things that we found out to get around this limitation, is that you have the initialize happens, and it has to happen the same way on both the server and the client. Otherwise, you're going to end up in a state where the HTML won't really match the DOM, and you've all seen that warning. So it has to be kind of like a pure action, where for any given bootstrap, it has to render the exact same regardless of what side you're on. So this happens on both the client and the server, but the client will take an extra step and kind of do like a 2-pass render. So initialize happens, the app is mounted, and then a second action happens. We call it app ready, that will fill in any other holes that might be like client-specific stuff, like getting stuff from local storage, or getting kind of like DOM dimensions that you need for something, or even like relative dates, because you can't send that down. You're going to end up with inconsistent HTML. OK, cool. I want to just pause for a second. Do we still have the slides? Just a second. Oh, here we go. My computer timed out. I want to emphasize that these, some of these examples that are being talked about right now are available on the Flux website as links. Andres has a repo as an example application to demonstrate what he's talking about, and Michael also has a lot of examples available on the Yahoo GitHub account, and those links are available on the Flux website. OK, so Andres, some of your apps are running Scala on the back end instead of Node. I'm kind of confused a little bit about how that is isomorphic Flux exactly. Yeah, so SoundCloud's infrastructure is mostly written in Scala on top of Java 8. So a Nashhorn is Java 8's JavaScript virtual machine. So what we've been playing around with is there's this the script engine. Okay, so because of the way we pack the applications, running them in Nashhorn is really not that much different than running them in Node. What we do is we go ahead and we take the application and we bundle it all together with Browserify. And if you've used Browserify, it's really good at abstracting away a lot of the Node stuff. So you can actually end up with a package that that is completely environment agnostic. You can run it in Node, Chrome, Nashhorn, whatever. So the way it works in Nashhorn is there's this script engine manager that lets you interact with Nashhorn and other types of environments you can get in Java. It works a lot like Node's VM module, if you've used that, or with like Contextify. So basically, it'll just run a chunk of code and inside of a context, and then from that context, you can run a function or pull any kind of values out. So it's within that context that we run the application. They have a start method basically that will go and do the initialize I spoke about earlier. And then just spit back out all of the HTML for the application, and then Scala will go ahead and send that to the client. So far, okay.
Interesting. So what really strikes me about your two different approaches, it sounds like, Andres, your approach is a little bit more like a very render-oriented approach, where it's not doing a lot of application logic on the back end, and it kind of like thrusts everything through the Flux code, the same Flux code with an initialization, whereas, Michael, yours is a little bit more stateful, where you're actually running more of a Flux application server side.
Yeah, I mean, we don't do a lot of state changes. It's mostly fetching logic that happens within the actions. It's really just that we're using the same fetching logic that we would use on the client for the server.
Interesting. Okay, Spike, let's turn to you. You're migrating a large Backbone handlebars app to React Flux a little bit at a time. What's it been like to incrementally introduce Flux, and what's been your approach to that migration?
Yeah, sure. So at Airbnb, we've been heavy Backbone handlebars users for years now, and we've got a bunch of Backbone all over the site and a few big apps. And our biggest app is this thing called Managed Listing, which lets Airbnb hosts edit their calendar, change their price, do all the things they need to administer their listing. And it's Backbone and handlebars. And recently, what we've been doing is, as we refactor it or add new features, we started using React, because we decided as an organization to adopt React for all kind of new client-side component development. And it works great, because it turns out that rendering a Backbone view, you take some class, you instantiate it, call render, give it a DOM element. It's pretty much the same thing as rendering a React component. And so we can just pick apart the Backbone app one piece at a time and replace it with React. And it works really well, surprisingly well, actually. It's really fun. And we've also been doing it with Flux. So what we started doing is, for the more complicated stuff, like I'm currently refactoring our calendar, we've wrapped our models and collections in stores. And so it's kind of a thin wrapper around the Backbone resources. And then we've introduced actions, and just basically Flux actions. And this has been really great for us, mainly for the organization that we get for app, because as many of you who are Backbone users know, it's pretty easy to create kind of sprawling ad hoc systems that don't have a lot of patterns. And so what we saw was a lot of our views and our models were like tightly coupled in an ad hoc way, and it was hard to understand the kind of the data updating mechanism. And if you wanted to hook into that, sometimes it wasn't clear how to do it, or it would take refactoring. And so now we've got the clear entry points for all the fetching and the data operations in our actions, and it's making it easier to just to maintain the app and to understand what's going on.
That's really interesting. I think it's very interesting how you're wrapping the collections and models in a store sort of like wrapper, instead of trying to implement the collections as a store. I think that sounds like a better idea than I would have maybe thought of. But I'm interested in how what you're using for dispatches, and like what kind of module you've developed to be dispatcher-like in that context.
Yeah, sure. So a while ago, when we started building Backbone apps, we came up with this idea of like an app model. So it's basically just a Backbone model that's like the application instance. And Backbone models have event emitters. And so we're basically just reusing this global dispatcher that we already had for our app as our Flux dispatcher, kind of as a migration path. And so far, it's worked pretty well. and we inject the app into our stores and our actions. They're not singletons; they're classes and instances, mostly for the testability, and just because I've learned to be afraid of singletons. And it works well. But the one piece that's missing is the wait for that the Flux dispatcher has, right? And that allows you to manage dependencies between stores. And so far, our stores haven't had many dependencies. But as I imagine, as we continue to migrate more fully to Flux and more of the application is kind of in that system, then we'll reintroduce like the typical Flux dispatcher and start to pull out some of the backbone guts. But it's kind of it's an incremental approach.
Yeah. I wanted to ask something that's really been a big question for a lot of people on Twitter or on Stack Overflow has been the issue of optimistic updates and how to do error handling. And Jing, I wanted to hear from you. I think people have talked about maintaining a client ID or some other kind of mechanism by which you would kind of like a dirty bit in a way that you're waiting to get validated. That's one approach, but the actions queue in Relay is something that's really interesting to me. I'd like to, if you could explain that a little bit more, that'd be helpful.
Yeah, sure. So I think the way that I think about it is if you take an optimistic update and you merge it directly into the store, without hearing back from the server first, what you're doing is losing information about the client state. Because you're merging it directly in, you have no way to get that original state back unless you also write an undo payload, which is kind of a pain. So what we were thinking with Relay is that's sort of an opportunity to solve it at the framework level. And the actions queue is kind of an idea I've had floating around a little bit. And I think this can be done in normal Flux as well, where if you just keep a separate queue of all the optimistic actions, what that allows you to do is if there's an error that comes in, we can pull the corresponding optimistic action out of the queue and then recalculate the state by reapplying everything inside of the queue because you didn't lose your original state. And then, if your server does actually confirm it, then you actually also pull it out of the queue, but you apply the server state on top of the original store state and then apply the other optimistic actions in the queue on top of that. And so what your view always sees is the original store plus everything that's inside of the queue. And obviously, every time something changes, you have to fire changes to the view as well. Is that a good explanation?
Thank you. I'm wondering if I might be able to implement something like that in a traditional Flux application.
Yeah, I'm sure you can.
We'll see. We have just a couple of minutes, but another outstanding question for a lot of people in the community has been routing and doing routing in a very Flux way. And I think, Andres, the way you described routing in your applications to me sounded very much like inside the Flux paradigm. And I'm wondering if you could describe that a little bit.
Yeah, so we don't do routing at the component level. We do it at the store level. So there's actually a route store. The way it works is that there's really no such thing as like a change route action or like any change route method. The route store will actually listen for any action that flows through the system, and it will then decide what is the route that needs to get, what component needs to get rendered, and that's what the root component will show. It actually works really well because the route store ends up turning into like the ultimate derivative store because it then listens to every other store to decide what it is that the next thing to show is. And so far so good. One of the things that we started trying with this approach is also instead of just passing, there's an identifier that ties it to whatever component we're going to show, but instead of doing that, actually send the component through. I'm not sure if that's a great idea yet, but we're still playing with it.
That's cool. I think we might have time for one question from the audience. Or I have a few more if we don't get one. Anybody? Yes.
So one issue we've sort of run into with Flux has been sort of reusability of components. And that you typically have a component in React and you can just put that other places in your code base, but when it's tied to an action creator and a store that aren't don't necessarily make sense to move to. Like, how do you decouple that, or do you decouple it, or I don't know.
Do you want to talk about that? You want to take that?
Yeah. So in our application, we sort of split up all of our components into two pieces. We have a container component and then a UI component. So the container component, its only job is to subscribe to stores and then gather the data and put it in React state. Then once it's gathered this state, it passes it via props to a UI component. So there's generally no state in the UI component, so it's really easy to reuse this UI component anywhere, and then the container is really lightweight, and you can hook it up any way you want.
That's great. Chris, do we have any more time at all? Got to cut it. All right. Thank you all very much for attending our panel today, and thank you panelists for being here. It's been a tremendous pleasure.